Okay, guys, good evening, and it's good to have you all here. And yeah, as you may know, this is the second Cairo Bootcamp that we are hosting as a community, that's Starknet Africa. The first one was held last year, and we had about 10 graduates, which most of them are going to be part of the tutors for this class. So this class will be this bootcamp will be running for 6 weeks, and we will have Kelvin, Pablo, Victor, Vic, and Wise Musa to handle these classes for us. And today we'll be handling the person that will be handling the first section today is Kelvin, which will give us a very deep intro into Starknet, Cairo, and also have Pablo who would give us who would show the practical section where he will show you how to um, install agents and deploy your first smart contract on Starknet. So let me just also give you a brief intro of what Stackware is all about. So Stackware is the company behind StarkX and Starknet, which are the two products that they are building, and they are based in Israel, right? So if you don't know, StarkX is a permissioned variety rollup, while Starknet is a permissionless decentralized variety rollup. So, and there's also a Starknet Foundation, which is a non-profit organization. So since we have already waited for 5 minutes, let's just kick off. Kelvin, you can just unmute.
Yeah, good evening, everybody. Can you hear me?
Yeah.
All right. So nice to have everyone on the call, and welcome to our second boot camp. And yeah, it's going to be an amazing 6 weeks. So I'll share my screen now.
Not able, we are not able to see your screen. Yeah, now it's happening.
Yeah, so can you guys see my screen?
Yes, yes.
All right. Yeah. So quick introduction about me. Ademola Kelvin, but you can just call me Kelvin. I'm a blockchain engineer and contributor to the Starknet ecosystem, basically. You can find my Twitter handle on Twitter. My Twitter handle is Code Whisperer. So today's agenda, since today's our like first class, we'll be taking a look at why Starknet, basically what Starknet is about, the solution, the problem they are solving, and how they are solving the problem, the architecture of Starknet, and some major components within the ecosystem that makes everything to function the way it is. And also, Pablo will be taking us to a practical session where we'll be installing wallets, we'll be interacting with, we'll be using our newly created address to interact and also to bridge assets and also to like interacting with smart contracts. So I would like take the class for a bit, and if you have any question, please feel free to drop your um, questions in the chat box, and yeah, and would have like 10 minutes break in between, so you can like take a recess and try and digest all the contents will be dishing out. I hope you're still with me. Hello, can you guys hear me?
Yes, we can.
Yeah, yes, you are clearly here.
Yeah. All right. So why Starknet? What is Starknet? Firstly we have to like go back to the initial let's roll back to Ethereum. Why do we have Starknet? So for distributed system, we know Ethereum or any blockchain is a peer-to-peer network, right? And the thing for distributed system or blockchains is that they can satisfy two properties of three, which is decentralization, security, and scalability. But then out of these three features, two can be satisfied fully. And using Ethereum as an example, I want to I believe we are all like familiar with like the normal the blockchains we have, Ethereum, Solana, and other blockchains such as Arbitrums and the likes, right? So using Ethereum as an example in this case, because Starknet is building on top of Ethereum, using Ethereum as an example, Ethereum is decentralized. It is very very secure, but then it has the issue of scalability, such that the amount of transaction that can be processed, right, is very low. And as you have more adoption, more usage in the network, you have to like you tend to like see that the rate of transactions become like the rate at which transaction can be processed become lower, and then you have surging gas fee and also decrease speed in processing of transaction. And this is a very very bad UX to this is a very, very bad UX to users, right? So this is where Starknet comes in. And the solution which Starknet uses is validity rollups to help scale Ethereum. So the ways you can scale the system, there are several ways you can scale Ethereum. You can either do on-chain scaling or do off-chain scaling. So on-chain scaling is when we're talking about sharding, which is still on the Ethereum roadmap, is yet to be in implementation yet. But then there are several off-chain solutions. An example is rollups, which Starknet is leveraging on. So what is Starknet? Starknet is a decentralized permission system validity rollup functioning as a layer 2 network built upon Ethereum. It powers DApp with remarkable ability to accomplish limitless computation. So basically, using rollups, right? Starknet is leveraging on validity rollups, stacks in this case, to be able to scale Ethereum. And what do we mean by stacks? What do we mean by validity rollups? We're still going to see these concepts. So, given you remember, I made reference to Ethereum, right? And the way I believe we all know how like uh, how transactions work and how transactions are processed into blocks and how the blocks are sort of and how finality is being reached, right? We understand that in Ethereum uses proof of stake, right? You understand that once transactions are processed and made bash in a block, right? Every node in the network still have to execute that transaction to ensure the state of the blockchain is valid, right? But then this brings a problem, right? Such that say you have five nodes, you have node A, B, C, D, and E, right? If such that once a block is run, right, node A has to rerun the execution to be sure that okay, this computation is actually very valid, right? So you have re-execution and waste of resources that way, right? So how do we solve this? So this is where Starknet sort of comes in. Use proof, right? Such that once the execution of a particular once the execution runs, you can generate a proof, and then um, you send the proof to the other person, and the other person doesn't need to run the computation. All they need to do is verify the proof. Now, in this case, you have transactions being run as minute fractions, right? Minute fractions. Where say an easier example would be, say you have two parties A and B, right? I want to prove to you that the computation of 2 plus 2 is 4, right? In the sense that for you to know that that is valid, you have to confirm from your own hand, right? But instead of re-executing that from your own end, what I need to do is, okay, do the execution as party A, and then give you a proof to verify that okay, this computation is actually valid. So everything we're doing is enabling transaction, enabling high throughput transaction, and also looking out for sorry, are you still following me, please?
Yeah, I am like
All
also
right.
Yeah,
All
yeah.
right. Any questions so far?
what is the difference between L1 and L0?
Okay, I'll take the questions soon. Okay, so now you have to generate the proof and send to the person. So the person B doesn't need to like re-execute that. All they need to do is just verify that the computation is valid. When we get to the architecture of Starknet, we get to understand this in detail. So the difference between L1 and L2, right? L1 refers to let's use Ethereum as Ethereum is an L1, right? While L2 are layer twos. Layer twos are off chain, right? They are not all layer twos are somehow like dependent on layer one, but layer twos are off chain solutions, like off chain blockchains. They have is like a they are off chain solutions to help scale layer one, right? So, and you have several examples of layer twos where you have Optimism, you have Arbitrum, you have Starknet in this case. And then the approaches to which this L2 takes to solve problems of scalability differs, right? So you can like look into other L2s we have, but we'll be focusing on Starknet. So talking about validity proof. So the basics of everything is an implementation of zero knowledge proof uses ZK proofs to guarantee computational integrity. Now we already established that we have an issue of scaling, right? And we want to be able to like execute transaction high um, number of transactions. And how can we do that? We can use something called zero knowledge. Zero knowledge. And using zero knowledge is basically like you saying you are proving something to someone without the person having the knowledge of the computation in this case, right? So when it comes to roll up, this is where ZK proofs sort of like come in. And there are different approaches in which you can generate ZK proof, but the underlying fact of everything is to ensure for computational integrity, such that if I perform a computation on Starknet, right, I'm able to like send proof to Ethereum and say, okay, this is the valid state of my computation at so block or at so time. So looking at stacks and snacks. So we already established that we use Starknet leverages on validity rollups, right? And this brings us to the topic of what do we call it? Brings us to the topic of proofs, right? We established that Starknet makes use of proofs, right? Validity proofs in this case. And there are different approaches in which you can like generate proofs, right? There are different proving systems that we have. And one example is we have SNARK, which is a succinct argument knowledge succinct argument I've forgotten. But basically Stark stands for scalable transparent argument knowledge. So looking at comparing stacks and snacks, so comparing stacks and snacks, they are both proving systems, but the way they work sort of like differs, right? We are not going to like go into the complexity of proving systems now, but then we'll just like take a look at some fundamental differences between them. So snacks involves the use of trusted setup in the sense that you have to like get you have to like get a number of people to like create common reference strings, right? There has to like be a ceremonial setup to be able to like generate the secret and a lot of things involved, which is somehow like less secure. But then looking at stacks are very, very scalable in the sense that they don't require trusted setup and they are quantum resistant. And the verification time is very, very fast, right? You understand that say you have party A and B, you're proving something, party A is proving something to party B, right? Where party A is the prover in this case and party B is the verifier. The verifier has to like verify, which means you're not re-executing anything. So the time in which you're going to like verify is very, very fast, right? So this is what this log hen sort of like means. So you have the proof size. When you're comparing the proof size of stacks to snacks, the proof size of stacks are always like large compared to snacks, but that doesn't like really have effect on how stacks work. So now, looking at, I know most of us might be familiar with layer 2 solutions such as Polygon, such as Arbitrum, such as Optimism, that they are, what do we call it? That they are EVM compatible, right? When you look back to the solution, or when you look back to solving scaling issues, there are two ways we can go about it. You can either create a system which is still like dependent, or which is like EVM compatible. When we mean EVM compatible in this case, when we mean EVM compatible in this case, we mean that the language in which you use to like write your computation is still similar and it is executable and recognized by the EVM, which is solid in this case. But your mechanism of executing transaction and processing transaction stuff like differs. But Starknet takes a different approach, right? We have the Cairo VM, which involves us creating a new programming language, right? Because why are we doing this, right? We are using proofs, validity proofs, and the way you can create this proof is to have a language, to have a proven language, right? Which you're still going to like see why we have Cairo. So this is the reason why we have Cairo VM, not EVM compatible architecture. So most VM architecture are focused on compatibility, while Cairo VM is focused on performance, right? So why Starknet? Starknet basically creates a system where you can create where you can verify where you can verify computation integrity, right? Remember we established that there is a scaling problem, right? And how do we solve this scaling problem? We create an off-chain solution. And how do we create this off-chain solution, right? One way is to like create an EVM compatible solution, right? Whereby you still write your normal solidity, but then your computation is done off-chain. But then another approach is using rollups, where we have the introduction of stacks, right? And then to build this system, we have to build something entirely different. You have to build a Cairo VM. You have to build a proven language, which is Cairo in this case. So Starknet guarantees computational integrity without re-execution. Proof verification is cheaper than the underlying computation. So Starknet is all about scaling, not privacy, right? And we mentioned zero knowledge, right? Zero knowledge basically means you're trying to like prove something to someone without like giving too much information. And sometimes this talks about privacy, but then we are not like putting our attention to privacy in this case, rather we're putting attention on scaling. Hence, while we're using stacks. Any questions so far?
Yes, yes, I
Hello.
have.
Yeah,
Yeah,
go ahead.
Calvin.
You are saying that Starknet is permissioned.
Permissionless.
I failed to.
Sorry.
Oh, permissionless.
Yeah, it's permissionless. Should have corrected that from my slide. Sorry, it's permissionless. Sorry.
All right. So okay, I thought you said permission, so I wanted to understand why you are
Yeah,
saying permission.
Sorry, it's
All
an
right.
error from my side. It's permissionless. Yes.
Okay. By permissionless means it's kind of decentralized. Or what
Yes.
does it mean?
Yes. It means it's decentralized.
All right. That's what I wanted you to clarify.
We are on the pathway to achieving that. That like the discussion around that might be out of scope for this class, but you get to like understand as the class goes on. Do we have any other questions?
Yeah, Calvin, can I
Yes.
ask one
Could you
question?
like speak up? I can't hear you.
Now can you hear you?
Yeah, I can hear you now.
Yeah. So my question is that what is the actual difference between this Bitcoin, Ethereum, and the Starknet? Actually, I do not have the clarity of L0, L1, L2. Can you just give a layman example to me to convince them what you guys are doing different as compared to L0, L1, that all of that? That's just I want to clear it.
Okay, the difference between Bitcoin and Ethereum, Starknet, right?
Yes, 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 Ken.
Yeah. So I'd like to this is like taking us away from the class, but I would like have to attend to your question. But I want to like ask you your understanding of these things. Could you like share your understanding of what you know about what you just asked?
Yeah, I ask on the basis of that. I also working in. I work in various different ecosystem, Calvin. But what I thought that L1, L0, and L2 layer are just like the like we are making a standard and one layer out of it and one layer out of it for making the scalability of these things, these technologies. So that's I
So
understand it is
yeah,
like.
so I'll just like give a brief answer about that. So everything still like falls down to distributed systems and peer-to-peer networks, right? And um Bitcoin is a blockchain on its own. Ethereum is a blockchain on its own, but with extra capability. Bitcoin, it's a it's a network that allows for exchange of value, right? But then without the ability to like execute smart contracts, right? But then there are currently ongoing works to like enable that. While Ethereum allows for exchange of value, but then with a little bit of extra capability to run any program. This is where you have smart contract comes in, right? Now, remember I said that when you are building like a blockchain, there are three major properties, right? You have this decentralization, you have security, and then you have scalability. But blockchains can only achieve two, right? So now Ethereum is an held one, right? And then how do you like solve this problem of scalability in the sense that when you have people come to the blockchain to make transactions, interact with one another by either sending through exchange of value or invocation of smart contracts, their actions has to like be processed, right? And you have such that the timing in which their actions are the actions in this case transaction being performed, the rate at which it is being processed is somehow slow. Then how do we increase this speed? How do we make this faster? This is where L2 comes in, right? And then there are different solutions you can use to like build L2s, right? So not to like take too much of our time, you can just like reach out to me. I'll share resources with you, and we can like continue the discussion further. So talking about, I hope you're good. Are we good on that?
Thank you so much. I get a clarity and we can connect later for more discussion. Thank you.
Yes, yes, we can continue the discussion later. Yes. So why Cairo? So we established that the Starknet architecture is entirely different, right? We are not creating an EVM compatible system. whereas we are creating something different in this case, while which we'll call like the Cairo VM, right? Now we need a that will be able to like use to write provable programs. And what do we mean by provable programs? In the sense that when you write computation in this case, say your smart contracts, right? The high level computation has to like be converted into proofs and be executed and sent to the L2 network to be able to verify that proofs. So this is where Cairo comes in. Cairo is a Turing complete language for creating provable programs for general computation. It takes inspiration from Rust. Yeah, the syntax is Rust and it is typed. Basically, Cairo is similar to Rust, but then there are some little differences. So if you know Rust, you can easily like pick up Cairo. But the basic idea is that we with Cairo we're able to like create provable programs. So still on the reason why Cairo, we are able to like create provable programs with Cairo. And what are proofs, right? They are basically like a provable, basically like a cryptographic proof is generated alongside the results. Proof verification can detect cheating or manufacturing without re-execution. The whole idea is to avoid re-execution, to avoid wastage of resources and allow for faster finality, right? So, what are the characteristics of this language? So it is high level language, is easy to learn, right? Compared to Cairo Zero. Cairo Zero was had like a steep learning curve. It is its syntax is Rust inspired, and it is compiled down to Sierra, which means save intermediate representation. So what Sierra is doing here is basically it allows it creates like an intermediary between our program. That in Cairo Zero there are several features that were not available, in the sense that, say for instance, when you are not able to like prove when a computation fails, right? So with the introduction of Sierra, we're able to like um, catch these errors and also like ensure like the security and ensure that we write like correct that we write safe programs basically. So you have your Cairo One smart contract. This is like the compilation process, right? You have your Cairo One contract being broken down, being taken down to Sierra, and then the Sierra is executed using a CASM, which in turn like generates validity proof, which is sent to L2. So summary on Cairo. Cairo is Rust inspired. You have Sierra, which allows for reverted transactions, and then we have Cairo One contracts on minutes already. So the idea of regenesis is basically I don't know if you are aware of this, but Cairo Zero is entirely like not entirely, but very like different from Cairo, the current syntax we have now. So the contracts written in the former syntax, right? They are going to like be disabled, right? So there is a minimum time of I think 6 months for projects to like transfer their code to the latest syntax. So regenesis is the phase in which this former Cairo language is disabled, and then every project will be in Cairo Zero. But as at now, there's still like for backward compatibility, right? So any questions so far?
Yes, Calvin, can I ask one question?
Yeah, go ahead. Can you like speak louder?
Okay, no problem. Now you can hear me better.
Yes, yes, sure.
So, why this language high level programming language? And I work previously in Rust ecosystem at Rust language. So can this Rust language help me to learn Cairo very faster?
Yes, yes. Basically, I want to like believe that, well, in my own opinion, right, all languages basically have the same foundation, right? You have data type, you have conditionals, you have um, yeah, conditionals, you have functions, right? They follow the same approach. The only thing you need to like get comfortable with is the syntax. So if you write Rust already, to be easy for you to like basically like pick up Cairo. And in this section, we'll be taking a look at the Cairo language itself, right? So if you know how to write Rust before, I believe it should be easy for you to pick Cairo. Yes.
Yes, yeah. And
Yeah.
I have one question other than this technology slides. Can I just ask, I want to launch my startup on Cairo network, so building some dApp for special solving real life problem. So what are the like opportunity we will get guys from you and making this ecosystem very separatable and growing in that sense. So that's I am also.
We can like talk more about that after the class. You can just like reach out to me and we'll take the discussion from there.
You can you please put your links that where we can, and we can also have a meet. Can you put your kindly then
Yeah, so
where we
I'll do that at the end of the session. You can just
great
like
great.
reach out to me on Telegram.
I Okay, I will try to search you on Telegram. No
All right,
issue.
all right.
Or
So
having a meeting with you also is better, Kelvin.
Jesus. So looking, this is like a simple implementation of a Cairo Cairo code. Now, I want to like mention something, right? So Cairo is not only for writing smart contracts, right? It's also a standalone language on its own where you can use it to write basically any computation, right? So this brings us to two major let me use the word terminologies now. You have Cairo programs and then you have Starknet contract, right? So Cairo programs are like normal Cairo codes you write, right? And the Starknet contract is basically you using using Cairo to write Starknet contract in this case, right? So we're still going to like see the differences. So you have this code defines a struct point with data type unit 8. So this, so you have like two data types. You have custom data type and then you have scalar data types. Custom data types are data types you can like create yourself, right? I believe you know that. And scalar data types are data types that are like sort of like available to you inbuilt from the program, from the language itself. So you define a structure that has x, y, x point x and point x, and it takes the data type unit 8 and unit 8. So looking at um yeah, we define a trait. So a trait is basically how you like define a blueprint, like you define shared behavior. So for some of us that have experience writing Solidity, we are familiar with the concept of interfaces, right? And how do we define interfaces in Starknet contract? Use traits, right? Basically, interfaces like define shared behavior, something like that. So use traits for that. And then once you want to implement your traits, you have this implement keyword. Then the definition and also the trait you want to implement. Then you define the function, the full function implementation here. So, but taking a look at Starknet contract, right? So, the way you write Starknet contract are quite different, such that you have to define um, using these attributes as Starknet contract to define that, oh, I am writing a contract here, right? And then you have mode simple storage contract. So what this contract does basically is define a storage variable called a storage variable with 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 the variable stored data, which is a uint 1 to 8, right? And when you define state variables, you have to like append the attribute storage to them. And then um, when you want to like you want to like implement the interface, the traits in which you define here, remember from the um, trait implementation here, it follows the same process, right? Nothing is really like different like that. So you define implement state, simple storage of super. So what the super is basically doing is, since this trait is defined in this module, you have to like reference it, import it into this simple storage module. If it is defined outside, you have to import the trait inside of the project. As you write smart contract, you tend to like understand how module work, and how you import files into your project. So basically, you have traits I simple storage, which defines a T contract state. You're referencing the contract state here. And remember that when you want to, on the blockchain, there are two major actions you can perform. You can either write to the blockchain or read from the blockchain. And still using Solidity as an example, when you want to mutate the state of storage, right? You either make your function public or external, and when you want to like read from state alone, you make your function view, right? So how do we implement that kind of mechanism in Starknet? So in this function, you have function set, right, which references the state of your storage, and then the parameter is expecting. So this ref self basically is saying you're going to like mutate state, right? Remember, from the function name, it says set. That means you want to like set storage in this case. So, but then if you want to like read data, where, right, you basically need to like get a snapshot, right? That is where you don't use the ref keyword, you use the self, which references the storage in this, which is the storage here in this case. Sorry, which references the storage in this case. So basically, if you want to like write to state, you have to like use the ref self and then append the add the type and the parameters it is expecting. And then if you want to read from state, you basically like have to get a snapshot of the state. So we are defining contract interface here. Reference modifies state, snapshot reads only. And when you define a contract, you define a contract with the mod keyword, and you have to append the attribute Starknet contract for the compiler to be able to recognize that this is a Starknet contract. Whereas in a Cairo program, you don't need to define anything of such, right? There are more configurations that enables this to work. When we get to the setting of development environment, you will see your scarp TOML file how you had your plugin dependency to be able to like to enable your compiler to compile these contracts. So we get into all those things in details, but this is still at a surface level. So here we are defining storage, right? We are defining the state of the contract, and here we have stored data, which is an unsigned integer uint 1 to 8, and then we have public method, external functions, where we are implementing the trait that we defined here initially, right? So implement set, we are mutating state, right? You pass in the contract state, and which this contrast state basically means this storage state here. Then the parameter is expecting, and you reference self dot store data dot write and hex, and then you pass in the parameter. So you're writing to storage in this case. sorry. So if you want to like read data from storage, you pass in self, which is still referencing like the storage here, and then you get a snapshot. Basically, a snapshot you're getting is just getting the data from state. You're not like mutating state, right? And the implementation will be self dot store data. So you have self dot what is the name of your storage variable here, store data dot read. So this function is going to return the value of this variable here. So any question so far?
Yeah, please check the chat box. There's some questions in there.
Okay. Uh, trait is not compulsory. Depends on what you're trying to do basically, right? If you're writing, no, I don't want to go into a code example. So traits is not compulsory, but when you want to like define shared behavior, right, that is when you use trait, right? I believe this will like get clearer as you like um as you write more programs. So what are reverted transactions? So reverted transactions basically is when when you execute transactions in MetaMask, right? And say your execution fail, right? It's going to like tell you execution reverted, right? But then it's you still charge you fee for that action that for that transaction that you ran, though the transaction was reverted. But in the previous Cairo zero that we have, once execution fails, right, we are unable to like charge transaction fee. We're able to like charge fee on this, right? So, but then with the syntax and the introduction of Sierra, all these things are these loopholes have like been gated already. So you have so everything works as expected, as it should be. Exactly, Elias. Does that make Starknet less secure? No, it doesn't make Starknet less secure. Starknet is actually like leveraging on Ethereum's security, right? So we'll get to like see this in the Starknet architecture. Can I proceed? Any question?
Can you
Um,
just
I sent a question to the chat box. You can check it out.
Okay. What do you mean as it should be? Did you mean to write it without taking gas? No, 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 no. Like as at that time, right? When execution fail, right, you're unable to like charge on that, right? But now it is gated in the sense that say your MetaMask transaction uh, you are familiar with MetaMask, right?
Yes, 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 yes.
Yeah. And you've like executed a smart contract call before, yes or no?
Yes, yes, yes.
You'll see that in have you like in instance where you like execute a smart contract and maybe that function call fails, right? You still like sort of like pay for that um you still pay for that for that function you
Particular
execute.
transaction. Yes, yes.
Exactly. But previously, when we were unable to like do that, right? Whereby once execution fails, right? It just feels like that, right? But then
Okay.
now you have Sierra, and then you have the new syntax, which sort of like gets these things and makes it work properly. Although this is not the only that was not the only loophole previously, but then there are several ones which I cannot like recall offhand right now. Or that's it basically. So just a recap of what we've done so far. We have we started like by taking a look at blockchains and the features they have, whereby we mentioned scalability, security, decentralization, and the issue which we can call trilemma issue in this case, whereby scalability is an issue, and how do we sort of like scale Ethereum in this case. There are two different approaches in which we can use to scale. We can either use on-chain scaling or using off-chain scaling. And one of the example of off-chain scaling is using is where Starknet comes in, using rollups, using validity rollups. Basically, it takes your execution away from Ethereum, right? It executes it off-chain, and we know that if you want to like execute like one of the examples of like off-chain, like creating off-chain solution is creating compatibility with EVM, right? Whereby you're able to write your computation in Solidity, right? But then your execution is on off-chain. But Starknet takes a different approach by creating its own Turing complete provable language called Cairo, right? And with this with this language, you're able to like write provable programs, and we're going to like see here how everything sort of like works. So looking at this will be a surface explanation about Starknet architecture, how it works basically. So in this section, in this TX that we're seeing, basically stands for transactions. Transactions are happening on Starknet, which is L2 in this case, right? So when you initiate transactions, the transactions are taken to the sequencer. So the sequencer is sort of like synonymous to nodes here, nodes that we know in Ethereum, right? So what the sequencer does is it orders the transaction and also executes the transactions, right? So once it executes those transactions, remember it's a proving it uses a proving system, right? This is why we have execution traces here, and I would not be explaining what execution trace means, but it's at the stack level, right? You have to like generate execution trace, and those execution traces are sent to the prover, and this prover is the one that is going to generate the validity proof for these transactions here. So you know that for every action, for every transaction you initiate on Starknet, right, it goes through the sequencer, which orders and then executes those transactions. You have execution traces, which is passed to the prover. The prover generates proof, right, and this proof then is then submitted um, to to the verifier contract on Ethereum, right? So and then on Ethereum, you have like the Starknet core contract. The Starknet core contract allows for L1 to L2 interactions and L2 to L1 interactions. So the basic flow is that you have your L2 off chain, right? Once you initiate a transaction, right, the transaction is executed, is ordered and executed using by the sequencer, and then execution traces are generated. And once the execution has been done, you have to generate proof. Remember, we're using validity proof. You have to like send the proof to the L1 in this case to ensure to say that okay, this is the proof of our computation. So at so state, help us to like validate and ensure that this verify the proof basically. So the sharp prover is the one that generates the validity proof, and then we submit the validity proof to the L1, and then the verifier contract verifies, right? Any question on that? So this Starknet architecture, it's more in depth than this, right? But this is like a surface introduction. So I think I think maybe at a later time we're going to like see are the functioning of these individual components: sequencer, the prover, the Starknet core contract, the verifier, and the sharp proof, and other components involved. Any questions so far? Let me check the channel. No questions. Okay. So we're taking a look at universal deployer. So what is the universal deployer? Now we understand from here that, oh, you initiate transactions and then you're able to like write smart contract and likes. But then how do we deploy our smart contract, right? You know that when you write your Solidity code, you can just like can basically deploy your smart contract, and then the EVM is going to like run the no, the required opcodes and have your contract deployed at a particular address. But then the universal deployer is what helps us to deploy contracts in Starknet. The universal deployer is a public good created by OpenZeppelin, and it is written in Cairo 0. Basically, what it does is takes in the parameters from your contract. Say you have constructor arguments, you have constructor argument that you want to like use to initialize the state of your contract, right? So um this UDC universal deployer basically help us to deploy help us deploy our contract. So smart contract that deploys other contracts that uses just one selector, which is like the deploy contract. So selectors must be invoked with blueprint class hash constructor argument. We are going to like see what blueprint class hash means in the next slide. Internally uses the deploy C score. Also, as time sort of like as we move on in the classes, we are going to like see the inbuilt method available to us that is provided by the network that we can use to like um that we can use in our day-to-day, like that we can use in our development. An example is the C score, which helps in deploying contract basically, which is used, right? It's a method exposed by the network to like deploy contracts. This is what the universal deployer leverages on, right? To clear up any confusion from that. So um using our understanding from Solidity, when you write your Solidity code, you compile and then you deploy directly. Here, it takes a different approach, right? You firstly have to like declare your contract. Once you declare your contract, and then once you declare the contract, you deploy the contract. Declaring the contract basically means you are registering the blueprint onto the network, right? So declaring registers Sierra code on L2, which is Starknet in this case. Declared code is also known as contract class. So when you declare your code, it's going to generate a class hash for you. Basically, you've registered the Sierra code on the network like that. You registered serial code on the network which generate a class hash for you. So once you are deploying, you need to pass in your class hash alongside your constructor argument if that has, right? So used as a library and blueprint. From blueprint, an instance can be deployed. Contract instances have internal storage. Every instance has a different address. So what we are saying basically is, say I have the code we have from here earlier. It's a simple contract, right? A simple storage contract. If I want to deploy this contract, I have to declare it first. And once I declare, I am registering the blueprint, right? And once I declare it, it's going to generate for me a class hash. And once it generates that class hash, I can use that class hash, right, to create several, to deploy it and create several instances of my contract. But then when you create several instances of that your contract, it generates like different addresses for you. So any question so far?
I am not getting Calvin.
Could you
Uh,
please speak up?
okay. Now it's okay.
Yeah, it's okay.
Yeah. So, like in Ethereum, we have remix ID to compile the all function and deploy this, and we
Yes,
directly deploy there before
yes,
declaring the things. So,
yes.
can you just tell me what is the difference between this, like we directly deploy as in remix ID and in the Cairo system, Cairo EVM compatible system for Starknet? What is the like we first declare, then we deploy? Can you just give a like brief introduction to this? Like, what is the advantage of it?
Um, there are really no advantages. It's just the way the system works, right? But I get your question basically. Using Remix ID, you can also you can also like write your Cairo contract with Remix ID. You can give it a try, and it will still follow the same pattern, right? You have to declare your contract first, and also declare and then deploy. Remember why when, let's say, in Solidity now, like on Ethereum, if you want to like deploy your contract, there are some abstraction that are done for you, whereby you sort of like prepare storage, you prepare a lot of things. I don't know if you've like taken a look at the um the should I use transaction details of when you deploy a contract. You basically have like the opcode run 60, 80, 40, 52. Basically those things are like preparing storage for you and doing some abstracted things for you, right? In this case, we can liken that to declaring our contract on Starknet, right? So what we are doing basically is when we declare a contract, you can't deploy a contract directly. You have to declare it first. Once when you declare a contract, you are registering it on the network. You're registering the Sierra code, right? And once you declare the contract, it's going to generate a class hash for you, and you are going to like use your class hash when you want to deploy, right? So if you have constructor parameters, you use your class hash alongside your constructor parameters. If you don't have any constructor parameters, um, you can just run like deploy and then you specify your class hash. So using that class hash, remember when you declare your contract, you're basically registering the blueprint, and remember it gives you a class hash, right? So when you reference deploy and then you paste in your class hash, it's able to understand, it's able to like pick from the system the contract in which you're talking about in this case. That is the contract you want to deploy exactly. I don't know if that answers your question. But you can also like use Remix IDE to write Cairo contract.
Yeah, great work, Calvin. I am very impressed from your.
Yeah, and you will see introduction to development tools that we use for writing contracts. So transaction types, right? We have deploy account, which basically deploys an account contract. You have declare, which registers the serial code of a smart contract. You have invoke. So invoke executes write functions, modifies state, and requires you to pay gas. So now the type of transaction you have deploy account, you have declare, you have invoke, and then you have call. So invoke basically invokes external functions that is write functions that modifies states, and when you execute external functions you have to like pay gas for those executions, whereas when you're reading from states you don't need to like pay any gas. It's let's say it's free in this case. Calling a read-only function is not a transaction, as it doesn't modify the global state. That is, so you're not paying any gas. So these are the type of transactions we have. So when we get to Starknet architecture, we get to like see transactions in depth. You get to like see transaction lifecycle, but this is an introductory class in order not to like overwhelm us with too much information, right? So these are the reasons why we're touching this concept at a surface level. So smart contract classes versus instances. So when you declare a contract here, you get the smart contracts class, right? Remember our universal deployer, right? We said the universal deployer supposed to deploy our contracts, right? So you have declare transaction. You declare you want to deploy your contract, right? You have to like declare it first, right? And once you declare it, you use your universal deployer, right? And you once after declaring, right, you have your smart contract class. Remember the class hash. Now we want to deploy in this case, right, to generate an instance of our contract for us. But then, so this is where the universal deployer comes in, where you pass in your constructor parameters, which gives you your smart contract instance, right? So you can, so once you have your contract deployed, you can now like invoke functions, right, and then call you invoke by modifying state, or you read from state. Also, aside contract call, we have library calls too. So basically, it follows the same approach. And once you start writing your smart contract code, you tend to like understand these individual components and how they sort of like fit together, right? But basically, it still falls back to this section where you have declare, deploy, invoke. Declare, when you want to deploy your contract onto the network, you have to declare first, which is going to register the blueprint of your contract, right? And generate a class hash for you. And once you get the class hash, you can use the class hash to deploy your contract. And once you deploy, you can start invoking functions on your contract. I think Pablo will be putting us through how to like deploy contracts, right? So you get a little snapshot of what class hash means and what deployment is about. So yeah, this is the end. So please throw do you have any questions on everything we discussed? Maybe something you need to like clarify or you're not clear on.
Is there like a community, maybe on Discord or Telegram, that we can like use like interact and get along? Then also the recording, is there any plan on how you to like be
Yes,
shared in case you want to listen to it again or something like that? Because I feel like it's important.
yes, of course. There's a community. I mean, yeah, there's a community. Um, I'll share the link on the call so we can join the community, and also the slide will be shared with you guys, and also the recordings will be shared with you too. So we'll take Paul, can you hear me?
Okay, yeah, I can hear you. Sorry, I didn't turn this on. So thank you for handling this section. It was a very good one, Kelvin. So we are going to have Pablo to put us through on the practical section for this class. All right. So Pablo, if you're there, just let me know. I've already made you a co-host, so you can just start sharing your screen. You're already running out of time.
Okay. Well,
So sorry
you
to
hear me?
interrupt. So for anyone that wants to join that wants to join the community, I dropped the Telegram channel in the chat. So that's our community. If you're free to join us and ask any questions, and yeah.
Okay, thanks, man. So, Pablo, so over to you, man.
Okay. Thank you, Paul. Uh, can you hear me?
Yeah, a bit more audible, yeah.
Okay. Okay. Nice. Uh, so for this, uh, to install our development environment, or let me show first my screen.
Okay, I don't know if you can see my screen. Hello?
Yeah, I can see the screen, but it's kind of like black. Yeah, I can see your screen, yeah.
Okay, nice. Great. So here for a little introduction. Pablo Tosi, I was born and living in DRC. Okay. I'm a software engineer at Quantum Vertex. So for languages I speak Swahili, French, and English as my third language. So you can reach out to me in these three languages. I'll be happy to share with you.
Sorry, sorry. I don't know if can you be a bit audible, please, if possible, please. We are finding it difficult to like hear you, Pablo.
Oh, okay. Let me change it. Can you now hear me well?
Yeah, I can hear you. Can hear you.
Okay, great. So we'll see how to create a wallet. How we can have some funds from process. We'll see how to communicate from layer 1 to layer 2. We'll bridge, and we'll see how to interact with smart contracts. We'll explore. We'll do some exploration of the blockchain using Wiregate and Starknet, and after we'll set up our scarf. So here for smart wallet, there is two main wallets using on Starknet. We always use as I said, two wallets. The first one is Argentix, and the other one is Bravos. We'll see how we can install these two. Let's start first with Argentix. If it's Argentix Starknet. Okay, I'll take this link. Sorry, my connection is a little more slow. No problem. And let me try to see how you can get Bravos also. This is written with 2A Bravos.
This class, the mechanism is good.
Okay. So what is a wallet? A wallet is a smart contract software enabling users to manage their account. Like it's allowing you to manage your keys, sign your transaction on the blockchain. This means you not need to sign your contract or using your keys manually. This smart contract will allow you to handle this stuff for you. So
it will be more easy for you to do signings and handling of this case. Like if you need to sign a contract, you just need to call this wallet and it will do all the stuff for you. Okay. So here I'll add it to my Chrome. I'll try to get those the same way the brothers. The brothers is ready. Okay. So here you need to create a wallet on this link. And create a password. This password just allow you to connect to your wallet locally. Okay, and here you have your recovery phrase. It is like 12 words. You can see, I can reveal it just for test. You can copy it and store it somewhere in a safe place. So I just say save this recovery word. Okay, so on Starknet, we have two networks. We'll take this girly alpha. This is designed for test, and the main net is the network which runs the whole blockchain on production. And as we are in development mode, we'll just take the girly alpha network. Oh, I don't have a photo. Let me see where the agent X is. Okay. The time this is loading, let's see agent X. We'll create. Understand, just click here. Check this boxes. Continue. We'll create a password. Spell this password. Right. The agent X is ready. Same to the bubbles. Let me take one. Okay. So here we have our Bravos wallet installed, and we have to set it up. So here we need some funds on our wallet, so that we can be able to deploy it, because we have to pay gas fees. So we have this gas fees to have this fund to pay gas fees. We need to have some
Hello, your voice is little bit
we need some tokens, and where to get them? We'll get them from faucet, we can click just in this link, like to get some info from Starknet, from faucets. Just click to this. Or you can just type like the faucet is the URL for the server. Okay, so how to know on which wallet we are going to transfer these funds? Let me come right here and say, let me pin it here. Listen way to this. Okay. Open your wallet. Don't know why it did taking too long. Okay. You can copy your wallet address. So this is your unique identifier for your wallet, and copy it in this field, or you can just click on this button and choose the wallet you want to connect with Faucet, or which you want to transfer these files. Let me take Bravos. Okay, I will accept. So it says cannot destroy property. I think there was an error. Let me try it again. Take the example robot. Okay, and the transaction is initiated. Okay, in this way, we are going to get some funds from Faucet to our wallet so that we can be able to pay the gas fees to deploy our wallet. In Underwood, wallet, as we say before, is a smart contract. This is why we have to deploy it. It's use the system of account abstraction. Is in the Underwood, it is just a regular smart contract. I think we'll have to see how smart contracts works in more deeply in future sessions. So let me check Faucet the funds as they are already initiated. Sorry, ma. Okay. There we can see that the file we already have some funds on the wallet, so we can deploy it. Let's click on this button, setup. Okay, this is the gas fee rate the amount will pay for deployment. It's completed. It is being deployed. The scenario is the same using Agentix. Let me close first this and come to Agentix. Let me say I will finish this. Okay, Here I can also connect my wallet and choose Argentix. Okay, connect to Drive. And here I have to choose Girly. First, let me come back here and say connect. Yeah, it's because we have to choose Girly network. Have to switch from main to test. Just say Girly. Let me create a plan for this. Okay, here we have our accounts. Let me copy this. Before continue, yes, we have to save this first and say check this account as I've already saved. Okay, let me take this. Come back to faucet. Check the and initiate the transaction. Okay, we can see here the transaction is initiated. I can close this. If you see, you open your Argentix wallet, the F is not yet there. But if you can see in the activities, yeah, there is a transaction. So how you can check if this transaction is already completed. This is where StackScan or Voyager comes into play, where you can see the state of your transaction. And try to hurry up as we'll be running out of time. Okay, here you can see the state of the transaction. Here it was the initiation. Okay, not yet received. Here the funds was received. Here there was accepted to layer 2. And here accepted to layer 1. We are waiting for this to be checked. So far, I don't know if there is a question so far.
Is this transaction hash is unique for every payment?
Can you speak louder, please? I can't hear you.
Now I am audible.
Yeah. Okay. Now you can.
Yeah. Yeah. Okay. Sure. So my question is that the transaction you are doing using this MetaMask, this is create a unique hash function. Like for every transaction we get, it's like that.
Okay. I'm not sure if I get very well your question, but MetaMask is used on layer 1 of the blockchain of its blockchain, and Bravos and Agent X are used on layer 2. So this token we have these funds, this transaction, a transaction on layer 2 of the if network. So after we'll see how you can transfer a token from layer 2 to layer 1 and vice versa. Of course, all these transactions are on Starknet will be transferred to the layer 1 so that they can be recorded on the Ethereum blockchain. Okay. Okay. So for this transaction, you can see all the state and all the data for this transaction, like taken, where they came from, and my wallet address, and the gateway used to transfer these funds. Here there is something we can share. Okay. This stack scan, you can browse all the transaction of the network. Like here, I'm on the test net. If I switch to the main net, you can see all the transaction on the blockchain. Oh, sorry, my network is now running slow. Waiting for this to run. Okay, here you can see the number of blocks, the number of transactions, the contracts that have been deployed, the classes and messages, and all the events on the blockchain. You can really explore all that. It can be what is all this? Let me click on this. You can explore all the blocks, the hashes, if they are accepted. All is here on this stack scan. You can also use Voyager. Say Voyager start. Next. You can also use this Voyager to explore the blockchain. Sorry for my network. Okay, let us put one address of the transaction we initiated here. I can come to browsers. Okay, let's take a look on this. Very slow my computer. Okay, here we saw this. I can copy this address and pass it here. Say not found. Sometimes it takes some time to be deployed. Or am I on the right net? No, I should be on Berlin network. Yeah, these are two platforms you can use to browse the network. Yeah, this is our transaction we initiated when we deployed our smart contract. And here you can see the status. It was already received on layer 2, waiting to be received on layer 1. Okay, so after this, how you can send funds from layer 2 to layer 1. In this case, we'll use gates. Right here. To see this gate, we'll use strike gate. Then you come to Starknet IO, and if you come here, ecosystem and bridge and ramps. You can see here a Stargate. If you click on this Stargate, it will open this site. So I'll just show the network. Okay, in the terms of loading, I don't know if someone else has a question about exploring a blockchain, Starknet blockchain, and wallet installation. Can you hear me?
Yes, we can.
Okay. If there is no question, we can go explore this. Let's see how we can transfer funds from layer 1 to layer 2 and vice versa. For here, for layer 1, I'm using MetaMask as my wallet, as you can see it. There is no pounds yet right now. So how I can transfer some fund from Starknet, like from using, for example, this Bravos wallet to Ethereum or layer 1 network. So here, what we'll be doing, I can just connect. I'll say it will come from Starknet because I have already some funds on this, and I'll be transferring this them on this my Ethereum or my Stark my MetaMask account. Okay, so let's connect the wallet. Okay, I say I'll use MetaMask. I'll admit and connect. Okay, and then I can connect to my Stack network. Let me take robots. I will approve the connection. Okay, it says please update network, the wallet on Stack mainnet. Okay, let us change as we were on mainnet. Let's take the Kali network as this is what we're using. This will take some time. Sorry for this. Okay, I will let it load. Okay, when waiting this to be loading. Okay, it's a load, we'll come for it a little later. Okay. I've already used using this Stargate, and waiting for this. Let's see how we can interact with a smart contract. For this, I will use one smart contract. It will be prepared here. This is the link of the smart contract. Okay. This is a smart contract just for transferring just dummy tokens. You can see it's for last code here. It's here a code which is possible produced when we declare a smart contract, as we said with PLP. This here a code for the smart contract. And here, this is the interface where we can interact with the smart contracts. We can read or write on this smart contract. They will say just for done transferring data, some tokens. I can connect one of my wallets. I take Agent X. Okay, I will approve the connection. And so here I've connected my wallet, and I can see what I can transfer some funds. What another gave me. Let me say I want to transfer 100 and right. my agenda is prepared. It's waiting for me to approve this connection or this transaction. Okay, it says it wants me to confirm this transaction. It says this will include what's our activation fees. Let me check. Is this transaction succeeded? When we took some fund for process. Let me take Bravos. Let me disconnect first this. Because I know on Bravos will have some tokens. Okay, I will approve the connection. Okay, disconnected. Yeah, I can write. Okay, let me say. And yeah, we can see the transaction hash is released. Okay, we can see that we transfer these funds to our wallet from our smart contract here. Yes, and I can check if I can check my wallet, the balance of my wallet. You can work here and say I can copy this the address of my wallet and pass it here and query. Yeah, we can see the 100 we transferred to using this one using this wallet. Okay. This is how you can interact with a smart contract. For sure, each contract will be different. It depends on the purpose of the smart contract. For this, it was just to transfer just dummy funds to a wallet, and how you can read these funds you transferred to your wallet. Okay. Yeah. So for this, we saw also we will check the status of the transaction on Starknet. You can even use Voyager if you want. It will be the same. Then both through Starknet and Voyager will just show you the state of the transaction and how where is it in the on the network. This is not one to load. I don't know why. Yeah. As we are running out of time, I can just jump this part and come back. Sorry.
I have a quick question.
Okay, go on.
So, like, I want to launch my own app on Starknet network. So, like, what are the facility like we get from the Starknet Foundation to like convert into it a big product for the users?
Sorry, can you repeat, please, the question?
Actually, I want to like deploy my DApp on Starknet network, the layer two
Okay.
solution of that you are making. So,
Mm-hmm.
like, what are the like invest like funding and networking opportunity I get from the foundation and the support of ecosystem? So that's I want to know.
Okay.
Yeah.
To deploy your your small project on Starknet. I'm not sure if I've got the whole question, but first, before you deploy your small contract on Starknet, you have to have your development environment set up, and you'll have to declare. I think this it will come in next sessions. You need to declare your smart contract. It will
I
produce
am I am asking Pablo. Question is that I want to like launch my decentralized application on Starknet network. So I like there is any funding opportunity for developers like us to go project to the a brief age from you guys your side to developing these great apps to Starknet. That's what I am.
well, sorry, I can't catch you well. I don't know if someone can translate what you say or say it again so that I can hear it.
Uh, can you hear me
I didn't get you
clearly?
well.
Can you hear me clearly?
Or maybe you can write it in the chat. I can read it, but I couldn't catch you yet. Okay. So the last part of the presentation, it's where to show you how you can set up your development environment, how you can start Star and Starknet. First, Starknet is the command line interface that allows you to interact with Starknet. And this is the command you can use to set it up. And this command works on Linux and Mac OS. For Windows users, I'll share with you documentation. I'll send it to you. So yeah, okay. As for me, I've already installed that. I'll show you how you can be sure that is already installed on your computer after running this command. First, this command will just download the installer. And running this Starknet app, this will install the Starknet. And after you can run this command, the last one, Starknet dash version, to see the version of your Starknet, and this way you'll be sure that the Starknet is already installed on your system. Let me show you on my computer. If it's Starknet, the version, you can see the version of the Starknet I am using on my computer. Okay. Okay. I let Paul answering this question after my presentation. I think he can give a better answer for this. Okay.
Yeah,
Yeah.
sure.
Okay. Okay. After installing Starknet, you have to set up these two environment variable. One for the location of the key store file for your signer, and one for the location of your account descriptor. This our wallet will handle these files, and this is the two parts of our wallet. In our wallet, we have a signer and an account descriptor. This account descriptor will find information like the address of your wallet, and other information related to description of the wallet. So don't worry about this. Your wallet is able to handle this on your place. Okay. Yeah. Okay. How to install SCAR? SCAR is say here is the package manager for Cairo and for Starknet ecosystem. Like we have npm for Node, or cargo for Rust. Here using Cairo, we'll use SCAR as a package manager. So it is easy, very easy to install it using on Linux and Mac OS. Just copy this link, this command, and run it on your terminal. And after you can check the version of the SCAR you are using on your system to be sure that is always set up. Okay, I'll show you the version I'm using on my system. If I missed something. Okay, sorry, I had to install this on this computer because I was using my my Linux computer. But this is how you can install it. I'm not sure we have time to explore it. We could install it together maybe. It's very, very easy to do so.
Can you please paste the install link to the chat so you can just copy and install it?
Yeah, sure.
This is valid for Linux system also.
And these are files, presentation file I will be shared with you. I think it's already in this chat. has already shared this. Yeah, you can just click on this link and you have all the material from here. Okay, I say for Starknet, the link for Starknet in the document. You'll get it from here. I prefer that you can just open this file and copy the links from here. So this is for Starknet. After running this for Starknet, you have to restart your terminal before you can run the Starknet command so that it can be recognized. Okay. Yeah. Okay, that's all for the presentation of environment setup. Waiting for this being installed. I just go Paul, if you can hear me.
Yeah,
Yeah.
can hear me too.
Yeah, okay. You heard it.
Command is valid for Linux also.
Okay, Paul, you have the floor. I think this is the end of this presentation. And maybe you can ask.
I lost you on the Starknet installation. So after running curl https get Starknet.
Okay.
So what next?
Let me okay. After running this, you have to run. You start first your terminal, and after run the Starknet app. You run this command, and after you restart again your terminal, and then the Starknet command will be available in your terminal.
It's not showing up.
Having these two tools, Starknet and Scrub installed on your computer, you'll be ready for Starknet and smart contract development. This will be the main tools you'll be using during your development. There will be any other tools. It can come as you are progressing in the development of Starknet smart contract. Okay, thank you all.
Yes, Pablo.